Everyone, welcome back. In this final video for this week, we're going to introduce two different things. First, we're going to talk about a new function called map, which is going to be a sort of Swiss Army knife of numbers when it comes to number manipulation in P5. And then we're going to do an example where we use this new function map and use it in the context of a for loop. And then while we do so, we're also going to get a little bit more practice with the for loop syntax. So let's get started. So I made a new sketch here. We're departing a little bit from the previous one where we just had all these random color circles. We're still going to stay in this colorful circle territory this week, but we're going to take things in a slightly different direction. So as usual, we're going to start off just by putting in some basic parameters here, and we're going to set the background to black for this sketch. Amazing. If I wanted to, right, I could throw in, remember we learned about events. So let's get into some good habits right off the bat. Oops, I'm just going to grab this really quickly, copy and paste, and make some delimiters for my functions just so I can know what's going on. We can implement window resized, and that's going to trigger whenever the window gets resized, at which point might be a good time to resize our canvas. This way, our sketch becomes a little bit more, dynamic, adaptable. If the window gets resized, it will update accordingly. Okay. All right. And yeah, so here we are. So let's talk about map. Okay. Now, before we do this, we're going to set up a simple little program here where we're going to have a white circle. Let's turn off the fill. White stroke. We're going to draw a circle, and just to kind of set the stage here, we're going to make things very, very explicit. We're going to set up these variables here that are going to define how this circle is going to get drawn. Okay, so we're going to really spell it out, and let's say we'll put a diameter of 200, put that into 3 variables, and then we're going to use the circle command, okay, and draw our circle. Okay, so even before we hit play, we can see that we're going to have the x value of our circle controlled by mouseX. The y value will be fixed, always at half the height, and the diameter will be 200. And then we'll take these 3 parameters and use that to draw a circle. Just a little aside and recap, by the way, this is the benefit of using lots of variables in your code, is now these functions, right, their parameters, the meaning of them becomes very, very obvious once you replace all these numbers with useful words, useful concepts. Okay? So all right, here we are. So we have our circle, and we'll just leave it at that. Okay, so we have a circle moving, following the mouse position. Okay, now let's say for some reason I wanted this circle to only be able to go, let's say, like, we're going to draw a line here at 200, from 200, 200 to 200, 400. Okay, so I'm going to draw a little bit of a line here. Actually, instead of the height, let's do that. Let's go minus 100 and plus 100, just so it's a little bit more fixed. Okay, so we're going to have a line here at x 200, basically. And let's put another one over at x width minus 200. Okay. Width minus 200. Okay, so I have these 2 lines now here. So by the way, remember, a line is just a point, right? XY, and then another point, XY. So this is the first point, right? This is this point over here. And then that is the second point. That's this point down here. Connect them with a line. We're doing the same over here. Okay? Just to make it a little bit more obvious what's going to be happening here. Now, let's say I wanted to still be able to, like, use my mouse position, but I would like this motion for the circle, right, to go from this line to that line instead, right? So this kind of problem, this kind of situation is something that's going to come up quite frequently as you're programming. Okay? The general concept and idea here is that we have a number that's changing. We have mouseX, okay? And we want to use that number, but we want to use it for something that the range of that new application is not the same range as the number that's changing. Okay, So mouseX values go from 0 to width. Okay, 0 to width. And let's visualize this even further. Okay, so map takes a little bit of time to wrap our head around, so I'm trying to make this as explicit as possible for this first example. We're going to use the text command to show the value of our variables. So let's see what that looks like. I'm going to go back to a white fill. I'm going to use text. So text takes a string. So we could say, let's say this is the value of mouseX. Okay, and we can put a string, and then we can add to this a variable. Let's say mouseX. And then I'm going to give it a coordinate. We're going to draw this like somewhere up here. 30, 30. Okay. Let's see what that looks like. Okay. And this is a little bit small, so we're going to say text size 30. Okay, a little bit better. So now we can make things very, very clear for ourselves. So mouseX, right, goes from 0 to width. Okay. And then right below this, we're going to put down the value of x. So x is our variable we're using to draw the circle. And we're going to line it up, and we're just going to move it down to 70 on the y-axis, so it appears below. Okay. So now we have these two numbers, right? And right now they're the same, obviously, because x is equal to mouseX. Okay. But in a second, they won't be. So what I would like to be able to do is to say, I want this circle to move, right, proportionally to the mouse motion, but I want to be able to limit its movement in this case, right? I want to be able to use this number 0 to 945 in this case, but I need this to go more like 200 to 745, right? That would be my ideal range of motion here, but the number I have to work with, mouseX, has a different range. Okay, so in other words, I need to translate a changing number from one range to another range. And this is the whole purpose of the map function. It allows you to map a number onto that has its own range, its own lower bound and upper bound, and map this to a new range where you're going to get to set what the boundaries are. Okay, so let's do an example. Instead of using mouseX directly, we're going to use the map function. Okay, so called map. We're going to open the parenthesis, and then map takes 5 parameters. Okay, so it's a little difficult to get used to in the beginning. We're going to outline what these parameters are right now, so we could look it up in the reference as well. But map is going to take 5 parameters. It's going to take an input, so some value we want to map. Then it's going to want to know what's the smallest number, right? And what's the biggest number that this input value can have, right? What should I expect to see? In this case, right, our minimum input is going to be 0, right? When the mouse is on the left, we can expect to see 0. We need to spell it out for map because it really doesn't have any understanding of or concept of notion of what this mouseX variable represents. All it's going to see is a number, right? So we need to tell it this number is going to go from 0. You can expect it to kind of exist between these two boundaries, from 0 to 945, okay? Or better yet, we can just call this width. Okay, this happens to be the width of my window. Okay? So mouseX varies between 0 and width, okay? Then the next two numbers we're going to put in are going to be our output min and our output max. So this is where we get to tell map how to do its job. It would be like, okay, map, I would like to get, right, this is what I'm feeding you. I would like to get out of this a number that's going to go from width minus 200, right? And it's going to go up to width minus 200, okay? In order to match the x coordinate of my two lines. Okay? So let's see what that does. And then we put in our semicolon as usual. Okay. So now we are using map to translate mouseX, right? We say mouseX has this range in the program. That means it will change as the code runs, but it will never be less than 0 and never be more than width. And please translate that to a number that changes from 0 to width minus 200. So now when my mouse cursor is 0, we can see that x is 200. My circle is perfectly lined up with my first line. And then as we increase mouseX, right, we'll see that now the circle is moving proportionally, right, and it's going to lock onto the final line as my mouse reaches the end of the window. Okay, so what we've done is we've mapped the mouse location to a new number, right? Where we get to decide the start and end point. Whereas if we just use mouseX by itself, we are always stuck to 0 to width. Okay, so this is very, very useful in many cases because now we have this slider basically with mouseX that we can use to control anything with much more fine control inside our program. And by the way, the input to map doesn't have to be mouseX. This is just very easy to demonstrate here. The input to map could be any other changing number in our code. Okay? Let's do another demonstration here. We're going to also map something else. We're going to map the diameter, right? So instead of using 200, let's use the diameter. We're also going to map mouseX. So as we go from left to right, I want this circle to start small and get larger. Okay, so we're going to map the diameter so mouseX goes from 0 to width, right? That's always going to be the same. But then the second part is where we get to decide what we want to see. Let's say diameter will go from 50 to 200. Okay? And then we're going to just use that variable to set the diameter of our circle. So now when we're on the left, we can decide, okay, this circle goes from 50 to 200, right? So we're able to do that now using map. Okay? Whereas without map, it would be very tricky to do this. We'd have to think of some fancy math way of translating mouseX into the correct number that we want. Okay? Just to make it super clear, we can also even just, let's draw our diameter. Move that down a bit. Actually, I added 40. All spiced out. So we can see both X and diameter are changing at the same rate, right? So the difference between the rate of change between the min and the max is the same. But of course, the boundary conditions, we can change the boundaries as we wish through map, right? So we're using the same input. Both of them are using mouseX as their guiding factor, but we're getting two different sets of numbers out of mouseX through map. We're getting a diameter, and we're also getting a position that we get to control. Pretty neat. Okay. Very, very cool. All right, so I'm going to save this sketch here. I'm going to keep that as a separate example for you to refer back to if you need a bit of a refresh on what is map really doing in a program. Again, it's always going to be the same recipe, right? 5 parameters, an input, a min, a max, and then a new min, a new max we want to get out of it. So map is super, super useful. Throughout this series of lessons, we're going to come up with creative ways to leverage map in order for us to do less work and do things more quickly. So it's a very useful tool. But in particular, there's one place where map becomes very, very useful, and that is inside the context of a loop. Okay, and so let's build an example around that idea. So I'm going to jump back here to to our old program where we had the colorful circles. Okay, and in fact, maybe we'll just start fresh here. So I'm going to keep a few things. But we'll get rid of these events. We'll just type the code again, just so we use this as an opportunity to refresh as well. So we're going to create our canvas. We're going to put a black background into draw. We're going to leave the color mode to HSB. And we can also remove background from here. Okay. All right. So to start off, we're going to recap what we can use a for loop for. So let's say we wanted to draw some colorful circles, but instead of having them all over the place, right, just randomly like we did in the previous example, what if we wanted to have a little bit more order, a bit more structure to our composition? Maybe we want to use a for loop to draw like a sequence of circles across the screen. Okay, so let's say we wanted to be able to draw 10 circles. Okay, we might write a for loop that looks like this. We could say, okay, for let counter equals 0, counter less than 10, and then counter plus plus. Okay, so these are the 3 ingredients of our for loop. First, we declare a variable we're going to be using to count with. Then we set a condition, okay? And then we set counter plus plus to determine the increment. Okay? So this loop here is going to repeat 10 times. Okay? So inside the loop, we might want to say, okay, we're going to go and we're going to draw a circle. Okay? Let's define, again, we're going to define our variables here for clarity. So the x coordinate of our circles, right? So what are x coordinates be? Well, in a second, we're going to use map to make this process a little bit easier for us, you'll see. But for now, we're just going to say, take the counter, right? And let's say we're going to multiply it by 10. Okay? Then the y value is going to be height over 2. We're going to keep those circles centered. Okay? Let's give them a diameter of 100. And let's set no stroke, fill white. Okay, so this is what we end up with. And we could play around with this this times 10 here. So we have the code here is repeating, drawing 10 circles. Now they're just really, really close together. So that's why it looks like this smudge. Let's increase this number to, let's say, 150. Okay, now it's a bit too much. 100. Okay, so we can see that we have 10 circles being drawn. Actually, they happen to be perfectly spaced. That was pretty lucky. That won't be the case if I resize here. Let's go with 70, and let's make these smaller just so we can see a little bit better what we're doing. Okay, so 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we've got 10 circles. And let's say, again, this is a common scenario. Maybe we want to draw a bunch of things. Maybe you want to have some kind of structured repetition in our code. Okay, whatever pattern we're trying to create here. But we want to position them. We want to do this layout a little bit differently, right? Maybe I want the first circle to be like over here, and maybe I want the last circle to be over there, or maybe I do want them to go all the way from the left edge to the right edge. Okay, who knows? Currently, like if we don't use map, we're kind of limited, right? We can use the counter inside the loop, right? So we can say this counter here, every time the loop repeats, the counter is going to take a different value. The first iteration, the counter is 0, then it becomes 1, 2, 3, 4. So that allows us to do the spacing, but this is a very clunky way of doing it. Okay? So oftentimes we're going to be using map inside the for loop to help us take our counter variable and use it for more than just setting the number of repetitions. Right? One way that I like to think about this is that every repetition of the loop, right, has its own number associated to it. So the first repetition, counter is going to be 0. Next repetition, counter is going to become 1. So we have like repetition 0, 1, 2, 3, and so forth. So that means that if we could map that number, right, if we could translate that number to something else, then we would have a lot more flexibility to use that number and plug it into all kinds of different applications. So let's do an example. So instead of trying to multiply the counter here to come up with a layout that fits, we're going to take our counter value and we're going to map it to exactly the range that we want. So let's use map here. So we'll take the counter as the input to the map function, right? And now counter we know is going to take a certain, is going to have a certain range as the loop runs. It's going to have a minimum and a maximum. So this is determined by the loop itself. Okay, so we're going to say the counter can go from 0, and what's the highest number that it can reach, right? Well, in this case, we say counter less than 10. That's our condition to stop repeating. So that means we'll never quite get to 10, right? If we get 10 repetitions, the counter on the last circle is going to actually be 9. Right? It's going to be 1 less than what we set because we use the less than sign, not smaller or equal to. Okay, so in other words, this condition will become false when counter equals 10. This is when the loop will stop. So the last iteration of the loop will end at 9. Okay? So let's put in 9 here. And then after that, once we've established, okay, as this code repeats, right, counter is going to go through this range of values, Now we can map it to whatever we want. So let's say I want to go from 0 to width. Okay. And then boom, my circles are now perfectly spread across my window. And by the way, because we are resizing, right, through with window resize, and because we're using the variable width here, if I resize this sketch, see, something cool happens, because now I'm using map, right, to take the counter. The sketch adapts, right? It will use the available space because we are dynamically calculating it over here. Okay. Pretty cool. Now, what if we wanted to change the spacing, right, even further? Maybe we wanted to go from 100. Let's make it more precise. I'm going to go from 100 to width minus 100. Okay. Now I can say the first one starts here, the last one ends over here. Okay. So we get to decide, right, what those boundaries are, and we can use map to take any number, whether it was in the previous example we were mapping the mouse, right, to get us to do this. In this example, we're mapping the loop counter, right? That's another very common thing to do. We're going to take our loop counter, which typically, I mean, is going to have numbers going up by 1. That's just, you could theoretically set up the loop here to have different increments, like to start counting from 100 and then increment in steps, right, to get you the correct layout straight from the counter. But I would advise against doing that, because that then becomes very difficult to think about the loop conditions and how many times your counter needs to increase by. So it's much simpler to have easy loops where you're counting in steps of 1, and then use map inside the loop to take your counter and then transform it to do different roles. Okay. For example, let's say we wanted these circles to get larger, right, as the program, as the loop repeats. Okay. So we could use map again. We could map our same counter, which goes from 0 to 9. Let's map it to circles that go from 10 to 100 in diameter, let's say. So now we have our first circle is small, our last circle is larger, because we are translating the counter at each step, right? We're mapping it to a different value that we can then use to do something slightly different, right? So the body of the loop is the same, but we're leveraging the fact that the counter is changing, so that we're not exactly doing the same identical thing at every step. We're changing the value of some variables, right? And then we're drawing technically the same circle with different variables being plugged into it. All right. Now you'll notice here, as we're mapping two different values, okay, I want to point something out that's kind of important. So let's say we change our mind here and we're like, actually, it'd be cool to have like 100 or maybe 15 circles, okay, whatever. We are going to have to remember to go and adjust this number to 14, right? Because now we changed how many times our loop is going to repeat. So it means the counter is no longer going to go between 0 and 9. It's actually going to go up to 14. And we've actually used this map twice here, so we have to remember to do it over here as well. So this is ripe for errors. It's ripe for forgetting. Imagine if we do even more, which we're about to in a second. We're going to also map the counter to a color, so we can get a nice little rainbow happening over here. So this is a scenario where it's very easy to forget, or maybe we change our mind here and go back down to 10, but forget to adjust these. So we can avoid all this by using the power of variables. So let's say we have these three quantities, right, are really meant to be, they're linked, right? They're linked with each other. So instead of having to manually update them, let the program take care of that for us. We're going to say, let's set the number of repetitions. We're going to call it n. Okay, we're going to use a variable, right, to set the number of repetitions. Now we have a letter or a variable name that we can use that's going to help us simplify our code a little bit. So the condition of our loop is going to become counter less than n. Okay? So instead of putting in the number 10, we're putting it inside this variable over here, which means our maps inside the loop, every time we want to map the counter to something, instead of having to think, okay, how many times am I repeating? We want to do one less than that. We're just going to say n minus 1. Okay? And then over here, we'll do the same. So now we've kind of generalized this loop a little bit. We said whatever n is, this is going to set the number of repetitions. And by the way, if you want to map this counter while you're repeating, just use n minus 1 as your max for the counter. So now this works, but this would also work if we had like 100 circles, right? If we had 5 circles, right? This would still work, so on and so forth. All right, let's increase the diameter here a little bit, just for fun. These get, go even larger. So these get a little bit bigger, and then we'll go maybe like 15 circles. Okay, so this makes it, again, every time you start to improve your code like this by, say, taking things that you would normally put in, hard-coded numbers and replace them with variables, right? You could do the same here with this 100, technically, because that defines the kind of this margin here that we set for ourselves. We could do that. Every time you add more variables to your code where it makes sense, what you're doing is you're making your code more expressive. You're making it easier to tweak and to change, and you're making the changes that you do kind of replicate throughout the program more easily. And as a result, if it's easier to change, it's going to be easier to work with, easier to go from idea to screen. Okay? So that's why we highlight these concepts. So let's add color just as a finishing touch to this example. So we're already in color mode HSB. So we're gonna make a hue here, and again we're gonna lean on map. I'm gonna say take our counter. So that's basically our repetition number, right? Our loop number, which we know varies between 0 and n minus 1. And then let's map this to a hue value between 0 and 360. We're going to go the full rainbow here. And then instead of a white fill, we could say, let's use the hue. And I'm going to be lazy and not dedicate 2 new variables for the saturation and brightness, because that was kind of pointless in the other example, because we're just leaving them at full value. And let's put in our 50% opacity again, just so we can see the circles overlap. Okay. Cool. And again, we can use map. I mean, we could use map if we wanted to set the biggest diameter of this this circle. Like if we wanted to map the mouse coordinate, we could do this. Or, sometimes just going simple works as well, right? So we could say, okay, this might be fine, right? This might be okay, but if this is like getting too out of hand, but we still want to make it a little bit interactive, maybe we don't want it to get bigger than that and smaller than this, we could use map again, right? Instead of we could use map here for these boundaries if we wanted to, right? So there we can have multiple layers of applications of map. So instead of using 10 and then 10 plus mouseX, we could have a separate variable. Let's call it diameter range, let's say, and or let's call it diameter max. We're going to map mouseX, which goes from 0 to width. We're going to map it to a number between, let's say, 100 and 200. Okay, and then here we could put in diameter max. So this is, again, we can use different quantities, map them to different variables, and then use these variables where it makes sense. So that allows me to control a little bit more how this range is changing over here. Okay. So sometimes it's okay to just use mouseX, mousewide directly if you just want to try things, just get some stuff changing. But whenever you want to start to get a little bit more precise, more intentional, try to think about how you could use map to help you do this. Okay. All right. Okay, so to recap quickly, right? So we created a for loop here, just as another example of introducing repetition. Unlike the previous example that we did, we made this for loop even better, because we define the number of repetition as its own separate variable. So now this whole loop definition is all variables, right? Such that inside the body of the loop, we can use map to use the counter, right, the number that's going up as the loop repeats, to make some changes to what's happening in the code at every step of the way. So even though we're always doing the same basic recipe here, setting a fill and drawing a circle using these three variables, every step of the way, the value of these variables is a little bit different because we are looking at our counter to decide what each circle should be. Okay? So this is an example where we're not relying on randomness as much, but more on kind of a linear structured way of getting the loop to work for us. Okay? And there's room for both. All right. So hope you enjoyed this week's lesson, and I'll see you next time.